Hello, friends. Jim here with Science Talk, and I have a very interesting findings to share with you. And this involves the Jakobshavn Glacier that's found on Greenland's west coast. So, what's going on with the Jakobshavn Glacier? Well, it's actually been growing a little bit in size. Now, overall, it has been shrinking. It has been losing ice mass, and it has been contributing to sea level rises. But now scientists are finding that it is also, at least for a little bit, growing in size. So, what's going on here? Well, there was a bunch of researchers from the United States and the Netherlands, and they hypothesized that the glacier is growing due to the presence of colder ocean currents. And what's the source of these colder ocean currents? That coming from the North Atlantic Ocean, some 900 kilometers away. And this cooler ocean current does pass close by to the Jakobshavn Glacier, and these waters near the glacier are the coldest they've been in since the mid 1980s. Okay. How do they know that these ocean waters are cooler? Well, NASA has a satellite mission that's called the OMG, and it does not stand for Oh My God. It stands for Oceans Melting Greenland, okay? And as well as other observations. The lead researcher is Dr. Ala Kazandar, who's a scientist at NASA's JPL in Pasadena, and he basically says, at first we didn't believe it. This took them by surprise. We had pretty much assumed that Jakobshavn would just keep going on as it had over the last 20 years, i.e., keep losing ice. But the cold water is not a one off. Data from OMG shows that the water has been cold now for 3 years in a row. Okay, so why is the water colder? This is the result of the North Atlantic Oscillation, the NAO. Now, I completed a lengthy series of videos discussing the major oscillatory systems of the planet, including the NAO. If you have not seen that video or the others, please do check them out. It does explain a lot of what goes on the planet. So, for those who may not have seen the video on the NAO, I'll give you a quick synopsis. Basically, it's a flip-flopping of what goes on in the North Atlantic. It switches between warm and cold water once, or about every 20 years. That's the current. There's also associated with the NAO changes in the low pressure system in Iceland and the high pressure system in the Azores. They're all in conjunction and work contingently together. Cold phase just recently started and has cooled the Atlantic Ocean in general. In fact, if you look at sea surface temperature for around the world, global sea surface temperature, there is one cool spot on the entire planet, and that's in the North Atlantic. Everywhere else, ocean temperatures, sea surface temperatures, are warmer than is usual for that region, except for the North Atlantic. It's the one little blue spot. And I'll be putting together some videos explaining all of that coming up soon. In addition to some extra cooling of the waters around Greenland's southwest coast, which then kept the glacier chilly and thus not as prone to melting. This is not, of course, not going to last forever. It's going to revert back. And then we're going to start seeing the Jakobshavn Glacier and other glaciers start to lose their ice volume. And the melting will continue as has been. Now, keep in mind, if I have a kilometer of water, liquid water, and whatever the temperature may be above freezing, and I want to increase the temperature of that kilometer of water 1 degree Celsius, it takes about 4 kilojoules of energy to do so. If, on the other hand, I have 1 kilogram. Right? So if I have 1 kilogram of liquid water, it takes about 4 joules, 4 kilojoules to increase it 1 degree Celsius. If I have 1 kilogram of ice, it takes about 80 kilojoules of energy to melt it. That's 20 times more energy. So now think about this. All that ice that is melting, being in Greenland, Antarctica, alpine glaciers, you start thinking about the volume of runoff that's happening. That is, to be blunt, a shitload of energy that's being absorbed. And where's that energy coming from? Human burning of fossil fuels. So, yes, this is interesting, but it does not forestall the overall pattern of what's happening, and that is we're losing ice volume, and sea levels are increasing as a result. Now, of course, you're going to get the climate change deniers. They're going to latch onto this one little bit and say, see, well, again, the overall pattern. Also, don't you think us climatologists, when we put these models together, we account for this sort of stuff. We account for the natural cycles. We do our statistical analyses and other analyses that are able to separate out the natural signal from the human signal. We account for all of this. So, of course, this new data will be incorporated to update the models, but we account for all of this. And by the way, I just saw something saying that all those models that climate scientists have put together and all the predictions they have made, yeah, they were right. All these predictions are coming true. As I said before, when we make the models, we're not just doing a what-if scenario. We're not throwing some shit at the wall and see what sticks. We take the data, we develop the equations derived from the data, we put it all together, all the parameters, etc., 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 and then when we get the models to replicate to at least 95, if not 99% correctness, to reflect what's already been observed, only then, when we get that high level of accuracy, only then are we comfortable with extrapolating as to what will the future bring. In other words, we know what the fuck we're doing, to be blunt about it. Okay? We know what we're doing. So, Dr. Josh Willis, also of JPL, and the PI, Principal Investigator of OMG, said Jakobshavn is getting a temporary break from this climate pattern, but in the long run, the oceans are warming. And seeing the oceans have such a huge impact on the glaciers is bad news for Greenland's ice sheet, alpine glaciers, etc. Now, scientists have been watching Jakobshavn for decades. They have been looking at it. After losing its ice shelf in the early 2000s, now an ice shelf is a structure that basically has the result that the glacier slows more slowly towards the ocean. Sort of like if you've got hair clogging a drain, that kind of deal. Pull the hair out and water drains out more readily. Jakobshavn began losing ice at an alarming rate between 2003 and 2016. Its thickness, vertical thickness, top to bottom, dwindled by 152 meters. That's about 500 feet. But starting in 2016, the waters flowing from Greenland's southern tip to its western side cooled by more than 1.5 degrees Celsius, which is almost 3 degrees Fahrenheit. And then the NAO caused the Atlantic Ocean near Greenland to cool by about 1 degree C, a little less, about half a degree Fahrenheit. So 1 degree C, let's see, 1 point, yeah, about that, between 2013 and 2016. By the summer of 2016, these cooler waters reached the glacier. And then they help likely to cool down the glacier. So you don't have that warm water coming in to erode the ice from underneath. You know, you have the air warming up, melting from above, but then you have warmer oceans. Warmer oceans will melt glaciers from underneath. I've discussed this many times when I discussed Antarctic glaciers and so forth. So what happened was that Jakobshavn slowed its rate of ice loss when this started happening. But in all, Jakobshavn grew about 30 meters taller between 2016 and 2017. But even though this is taking place, the glacier is still contributing to sea level rise, as it is still losing more ice to the ocean than is gaining from snow accumulation. In other words, the NAO is only staving off what's ultimately happening, just slowing down how much loss. Dr. Tom Wagner, a NASA headquarters program scientist for the cryosphere, which cryosphere is anything related to frozen stuff on the planet, right? Permafrost, sea ice, anything frozen. These findings shed light on how much ocean temperatures can affect glacier growth. This this article was published in the journal Nature Geoscience. So this is interesting. It shows the importance of what is happening around the planet. And it shows the importance of continuing to do the research, to continue to get new data, to update the information, which only helps us better understand mechanisms. This also goes to show that this is a very complex system. That should not come as a surprise to anyone. But when we have enough data, we can tease out natural signals from anthropogenic signals. So what's the bottom line? Okay, Jakobshavn increased a little bit in size. It is still overall losing, from other locations. It is still adding water and contributing to sea level increase. This is temporary. It will go when the NAO flips its mode again. Jakobshavn will go back to losing loads of ice to meltage once again. But keep in mind, there are other spots on Greenland that are also, losing ice and not accumulating ice. And go back to what I said earlier. Have a kilogram of liquid water takes 4 kilocalories to increase that 1 degree Celsius. Kilogram of ice takes 80 kilojoules to melt it. 4 kilojoules, 80 kilojoules. 20-fold difference. That's a lot of energy. That's for a kilogram of ice. Do the math. What's the volume of Greenland's ice? How much is melted? And that will tell you how much energy has been put into the system to melt just those guys. Not even including Thwaites or Pine Island glaciers down in Antarctica. Not including the alpine glaciers in the Himalayas, the Alps, the Rockies, the Andes, etc. Glaciers around the world. A lot of energy being put into the system. So, thank you for your time. I wanted to share this, what I thought was a curious story with you, but also keep in mind, as scientists, we account for such things. And now we have this information, we'll make the necessary adjustments. And after making the necessary adjustments, say, yeah, it's still overall adding water to the oceans. But new studies have shown that the models that we've developed, the predictions we've made, are correct. We know what we're doing. So if anyone tries to BS you or gaslight you, what have you, you can basically tell them, no, scientists are correct. They know what they're doing. Thank you for your time. Hey friends, this is Jim reminding you to subscribe and share my videos. Also, don't forget to click the bell so that you know when I drop a video in. And I'm also asking for you to please support the work that I do by becoming a patron at patreon.com. Details in the description box below. Thank you for your continued support.